Hi, welcome to Emerald Hill Skies. My name's Doug. We're operating from the outskirts of Louisville, Kentucky, and we've got a pretty cool announcement tonight. Here you can see on the left the announcement by Koichi Itagaki of a new supernova. Now, what makes this supernova unique is that it's so bright. I want to take you right away to our planetarium software, and we use Starry Night Pro here. We're looking here at two galaxies that are located in pretty close proximity. M60, Messier 60, is right beside NGC 4647. Now, this is a picture of what the star map would have looked like down through the last couple of decades. You can see that these two galaxies are pretty close together, and between them there's really nothing to note. What we want to do now is we want to see what Koichi Itagaki found here between these two galaxies. If you look at the M60 here and NGC 4647, he found this bright star and it just exploded. Now this happens quite often anymore, at least it happens that we discover them quite often anymore because of all the big sky surveys that our automated telescopes are doing 24/7, 365 days a year. What makes this supernova unique again is it was discovered, as far as I can tell, by a guy, and this guy found this thing just as any astronomer could, any amateur astronomer. It's called 2022HRS. Now, the way these supernovae are named is you have the year 2022, and then the nomenclature is you let these letters stack up, and you have all the A's and then all the B's. Well, we're up to the H's already. That tells you how many supernovae have been discovered. Then from H, you have all the A's and B's and C's. Well, we're up to the R's. And then once you get the R, you have all the A's, B's, and C's. We're up to the S's. So this doesn't stand for 2022 hours. Nothing related to that. It's just coincidence. The actual name of the supernova is HRS. Let me make sure I get this correct. SN2022HRS. So that's SN stands for supernova. 2022 is the year, and then HRS. So this is the announcement as it was parsed from the announcement that he made here on the transient name server. And it's the Supernova Working Group. It's echoed out by a lot of different groups like Purdue and a bunch of others. But what's exciting is this supernova is so bright. And what we're going to do right now is go to this telescope. It's a RASA 11, and it's right here at Emerald Hills in our observatory, about 200 feet from where I'm sitting. And that's a live view of the telescope that you're seeing there. Now let's go to a live view of the sky. That's the actual portion of the sky that we're looking at, kind of like due south toward constellation Virgo. Now let's go to the actual view of, let's view through the telescope itself. And to do that, we're going to go over to our live camera view of our ZWO ASI2600MC Pro. And right away, this is not a stacked view. This is a 3-second exposure being caught as snapshots. And we can start stacking this if you want. But I just wanted you to see how bright this is in context of the night sky. Let me make sure that our audio is coming through here. Yeah, just wanted to make sure that our audio is coming through. What I'm going to do now is turn on our deep sky image annotation. And this will show this big circle is M60. This smaller circle is NGC 4647. That little dot is a dot that didn't exist before. Well, let me rephrase that. It existed before, but it was just a star that was out there minding its own business. probably magnitude 30 or something. This bright new star right here, let's zoom in on a little bit more. This bright new star right there is now, I would guess, magnitude 12 or something. I don't know if it's going to tell us this. If we go to, well, here it's magnitude 15. When he charted it on April 16th, it was magnitude 15. I don't know if we're able to see what the magnitude is right now. It was discovered at magnitude 15. I mean, if I were guessing, I would say this has to be at least magnitude 10. Here is a view 12 hours ago by another amateur. His name is Siegfried Trotnig, and he's down in Chile. And I don't know if he guessed what magnitude it was. He didn't. We're going to have to conduct some studies of our own. You know, if you do a web search on this particular supernova, you don't find too much about it. I mean, maybe you'll find, well, here we got it, 4 pages in Google. This is brand new, and here's the announcement, just discovered 5 days ago by Koichi Itagaki. This is a big deal, and this supernova is a particularly big deal because it's so bright. So let's start stacking this. We're going to go up to our sequencer, and by stacking, we mean that we're going to take 20-second time exposures, one after another. And as these time exposures add up and stack one on top of another, our imaging program, we use a program called SharpCap, it begins averaging the light views. And it's going to pop out here for us to see any second. There's our first frame, and we'll just do a color balance on these using our white balance tool down here so we can line up these peaks down there in that histogram. Now let's bring this black level over to about right there, and let's bring the mids down to about right there so we can make this a little bit brighter. Now once again, that's M60 on the left, and that's NGC 4647. This supernova is already, after just a 20-second exposure, way brighter than M60. So let's go over here in Starry Night Pro, and let's look up M60, and let's see if in our info here, see if it gives a magnitude. M60, oh bummer, it doesn't really estimate the magnitude here. Oh yeah, apparent magnitude is 9.79. Well, this supernova is, in my estimation, brighter than, if you ask me, it's brighter than M60. It's at least the same. So this supernova is already up to magnitude 10. And we now have 5 frames stacked. And so it's going to continue to make this supernova more pronounced. Now we've got it pumped up here to 186% of our camera's optical capabilities. So we'll dial it back down. There's no sense in dialing it up because it's always going to look like a pinpoint as a star. It's going to look like a pinpoint. But wow, it is at least as bright as M60. So this is a pretty big deal. Once again, let's put the deep sky annotation on so you can see where we're looking here. This wider circle is M60, and the smaller circle is NGC 4647. Let's go to our planetarium software, and let's kind of back out so you can see what part of the sky. This red rectangle is roughly equal to what our RASA 11, that's the optical tube assembly that you're seeing there of our RASA 11 and that snapshot of it. We're using this equipment up on top of the RASA 11 to allow us to have, for instance, the sky image here of the portion of the sky that we're looking at. The camera we're using is this little red camera here on the end of our RASA 11, mounted on the front of the corrector plate. This is a ZWO ASI2600MC Pro. And this is a live view that you're looking at now here on the left. That is a live view of SN2022HRS. Supernova just discovered 7 days ago now. So in our planetarium software, let's back off enough so that you can see where we're looking in the sky. This is the cardinal compass point of south, and here is southwest. So if you would look straight up in the sky above, I guess it would be southwest, a little bit south of southwest. So we'll call it south-southwest. You'd look up straight in the sky. Let me put a few more constellations up in the sky. It's right below the constellation Coma Berenices. And just again for orientation, here's the Big Dipper, or the Plough as they call it in UK. That's kind of in the north part of the sky, but look at the way this handle is over the top of the south-southwest these days. If you were to zoom in right here, you would see in the south-southwest this view of M60. And if you zoom in even more, you'd see M60 side by side with NGC 4647. And there's NGC 4647, very, very dim. And here's M60, and there's this new supernova. That's 5 minutes worth of data, and we didn't even need that much. This supernova was already showing up in our frame with just the 3-second snapshots. So we're going to take a saved image of this because this is history. We've seen supernovae down through the years. The first recorded supernova that we have back in history is recorded in 185 AD. It's the oldest supernova that somebody actually started talking about. But in 1054, perhaps the most famous supernova, that's the one that lit up so brightly that it was observed during daylight. It was the astronomers of their day, of that day, they recorded this, and it was said to be so bright that you could observe it in the broad daylight. It was 4 times brighter than the planet Venus, and for 23 days you could see it during daylight. In the night sky, it was visible for the next 2 years, and it became the Crab Nebula that we still can look at today, M1. It's a supernova remnant. Well, this view that you're looking at tonight is that kind of event. It is so bright, and we are happy that you were willing and able to check in with us tonight. And I see a couple of people here that are observing with us live. Thank you for being up in the middle of the night at 2 a.m. to be able to see this. Thank you for watching this. If you're watching this as a recording, if you like content like this, I hope you'll subscribe and also click maybe thumbs up. It won't cost you anything, but it'll get the content higher up in the YouTube searches that other people do. Maybe go ahead and click that bell if you like, and then you'll be notified of content like this. Thanks a lot for joining us. We're going to sign off on this particular live stream. And once again, thanks for being a part of this Supernova 2022 HRS near the galaxy NGC 4647. We're thankful to God that He made this so that we could look at it tonight, made it so visible for us to view live. Emerald Hill skies. Thanks, and have